Hey, what's up? Welcome back to the Texas channel on YouTube. So today we're gonna talk about math. We're gonna talk about pre-algebra. And we're gonna talk about things that are very simple but also very important to understand in math. A lot of people don't understand this, and remember, understanding better than memorizing. Because once you understand something, well, you understand it. That's great. So let's go. Knowledge. In math, expressions like, oh, 5 plus 5, right? Oh, that's an expression. Then we have this. Oh, what is this? The equality, right? The symbol. 5 plus 5 is 10, right? So now we have an equation because of this. Okay? Now, there's algebraic expressions in which we not only have integers, we also have letters, in this case variables, or simply things that we don't know what is their value. So for example, this one, the variable and the number that we don't know. So in this case, A is the number that we don't know. We don't know. Now, I just got out of my ass, so I don't even know if this is right. But let's do it. So, we have this, right? And we need to solve for that. We need to know what is this thing? What is the value of this variable? Well, in that case, we basically need to solve for it. That's how you know about it. We need to solve for the variable. So, how do you solve for the variable? Here's the thing. So, to understand this, we gotta look at this as if it was like a balance, right? So we got the balance. Not my best drawing, but we gotta understand it that way. So in order to get here, we need to unwrap the equation, right? That's the first thing we gotta understand. We need to unwrap it. If you knew, or if you have lived under a rock for the past 200 years, we know that in order to solve an expression, a normal expression, we need to do something like, we need to do PEMDAS, right? I don't like saying PEMDAS because PEMDAS is just a way in which it's just a rule, but it's not like the actual nature of math, basically. But yeah, PEMDAS is easier to understand, so we have PEMDAS. I'm not gonna write it. You have PEMDAS, right? Which is parentheses, expressions, multiplication, division, addition, and subtraction. So basically, that means that if you have an expression where there's all those things, the first thing you gotta solve is what's inside the parentheses, then either multiplication or division, and then at the end, it's addition and subtraction. That's creating or solving an equation, solving an expression. In this case, if we want to solve for a variable, we need to unwrap. What does that mean? Undo. What does that mean? Do the reverse of. What does that mean? Do reverse PEMDAS. So do PEMDAS literally the other way around. So if addition slash subtraction was the last thing we need to do, that's the first thing we need to solve for. And that's the thing here. Now, obviously, I have a very simple equation here in which there's no multiple, math tools like division, addition, or whatever to demonstrate this. But basically, you need to unwrap the equation. Unwrapping this, you basically need to unwrap the equation in order to get to this that we want to know. Okay? So in this case, we have a times 15 equals 25. This is multiplying. So how do you get rid of this? You need to get rid of this, right? Remember, we want to unwrap the equation to get to this. In order to get to just this, we need to get rid of this. So how can we get rid of this? Okay, that's how we know. Okay, what is this doing to the variable? This is multiplication. Okay, what's the inverse of multiplication? Division, right? Or in other ways, it's just, okay, we want to get rid of this. So we do this, and by doing that we have 15, which obviously we know is equal to 1. So in this case that will be equal to A1. We didn't ever write a 1, so that's just A. There you go. So, I mean, I was gonna say we cancel it, but it's not really cancellation. As you can see, there's still something, right? But it's easier to explain if we cancel it. So in this case we do that, but here's the thing. We do that same thing on the other side, because back to our balance, basically we have A15 here and we have 25 here. We want to do the same thing that we did here in here, because if we get rid of this and we leave this as it is, then our balance is gonna be like not balanced. It's gonna be something like this. That's not balanced. So what does that mean? That this is not the same as this. Let's say that these are weights. Obviously, if you look at this, well, this is clearly not the same weight as this. It's the same thing here. If we did solve here and didn't do anything to this, A is really not equal to 25. And you can actually prove this mathematically. You just do the same equation, 25 times 15. So you basically put the value of A into the equation, and 25, 15, 25, 12, 5, 2, that's clearly like 375. It's clearly not 25. So what do? We need to balance it. So in the way in which you balance this is that the same thing that you did here, you need to do it in here. So in this case, you divide it by 15, so you divide by 15 here too. And that way, you're gonna balance this stuff. Oh my god, why am I using my fingers? That way, you're gonna balance again this stuff. You're gonna balance it. So that is equal to A 6, 6, and I'm just gonna put this because it just goes a long way to go. So that's the result. In that case, as you can see, now this is balanced because we did the same thing that we did here. We did it to this part. And we balance the equation, which in math terms, it just means that it's equal. So I think that's a really great way to understand this. Like if it's a balance, and I think you just clearly understand why we're doing all of this. So that's it, right? Now, there's another thing. Let me just do another as an example. In this case, it's multiplying, we need to divide. We need to do the same thing here in order to balance it. And boom, the result. So the result you already know. This cancels out. Well, it's not canceling, but whatever. So it's 9. So now we have our answer. X equals 9. There you go. And that's actually true. Now, that's very easy, obviously. But it's just a great way to explain it. Now, what about this situation? Because this is something that is really important to understand. What if we have something like, I don't know, let's say 7 over x equals 69. Let's say we have that. In this case, what a lot of people will do is something like, oh, this is clearly division, right? So what's the inverse multiplication? So let's do that to get rid of 7. So they will do something like this. times 7. And they do that. And yeah, they get rid of this. But at the end of the day, okay, they do this, and then they need to multiply, and then 69. 69 times 7 is 400. 483. So at the end of the day, they have this, right? Now let's actually see if that's true. 7 over 400. That's not true. In reality, that's 0.014, etc. So here there's clearly something wrong. As you can see, this is not the same as this. So there's a problem here. Now what is it? Well, here it is. Basically, there's this rule that you, like the first thing, like first of all, when looking at this, where's the x? The x is on the denominator, right? As we know, this is the numerator, this is the denominator. Basically, we need to make the denominator, the variable be on the numerator in order to solve for it. So here, the first thing we need to do, non-negotiable, is get this thing into the numerator, okay? Why? Well, you just saw it. It just mathematically just doesn't make sense to do it that way. Basically, we gotta have the variable in the numerator in order to solve for it. That's why whenever we have this, that's why we can actually solve it, because we don't need to do anything at the beginning because the variable is already in the numerator. Okay? Even the same thing with this. In here, the x is in the numerator. Okay? All of these numbers, even if there's not a fraction, like they are on the numerator. So that's where we can do that. But in this case, the variable is in the denominator. So the first thing we gotta do is just get rid of that. Like we gotta make the variable be on the numerator. So in this case, how do we do that? Well, we need to basically multiply the fraction times the variable, right? So in here, since it's division, and then this is gonna be times x, which is basically, we get rid of this, and now we have this. Now we do have the numerator the variable in the numerator, so now we can proceed. I just wanted to tell that because that's a problem that a lot of people struggle with and they don't even understand why. But here's basically the thing. We gotta always, like if the variable is in the numerator, we gotta put it in the, if the variable is in the denominator, we gotta put it in the numerator in order to solve for it. So in this case, we just do it right. So now we can actually do this. Now how much that is. So now we have 0.101 equals x equals. Okay, so now let's do this. This actually gives us 16, which is the same thing as this. So that's another very important thing that I needed to say. Now, so far we have just seen very simple things in which we just have one variable. But what if we have
another one?
What if we have
another one?
The same variable on both sides? Because so far we have had the variable in one side. What if we have two sides? Well, that's what a lot of people call to solving a two-step equation. So here's the thing. Let's say we have 7x equals, let's go with the same one. Now in here we have a 2 in both. What we gotta do in this case is combine both terms, because as you can see they are like terms. They both have the integer, they both have the same variable, so they're like terms. So we gotta combine it. So I don't know, it can be either moving this one into here or moving this one into the other side. I'm gonna move this one to here. So now that will be 69x minus 7x. Because, I mean, I'm just gonna do it the full process to understand. So, 7x. 7x. 69. This is cancelled, so it's 0. And this 62. So now we have that. In this case, we gotta solve for x of 62. This is a 0. So x is 0. Right? There you go. Now, I'm gonna put another example. But basically the thing here is you gotta, if you have the variable in both sides, you gotta combine them first, and then once you combine them, you can actually solve it. Here you go. There you go. Here's a great example. As you can see, we have the variables in both sides, in this side and this side. So obviously first we gotta do is combine like terms, as we already know, right? So in this case, we gotta combine this one, we gotta alter them. So plus 8k. And now here's the thing, we gotta combine them, so I'm gonna move this one to here. So minus 4 minus 4. Okay, that leaves us minus 4 equals 8 plus minus 4k. So now we just have one variable in one side, and we already know how to solve this. That's why they call it 2 steps. The first step is basically having the variable in one side, and the second step is solving it, as we have already solved it. So, I mean, I'm not gonna, you already know how to solve this, right? So, that's the thing with solving for variables. Obviously, it's gonna be increasing in complexity, but it's a great foundation, and great foundation to understand. So there you go.